Hello statistics and probability students. In this video, I will discuss random variables and probability distribution. The references that I used are the DepEd modules for statistics and probability and statistics and probability for senior high school by Ricardo B. Banigon Jr., Maita G. Camilon, and Catalina B. Manalo, published by Educational Resources Corporation, 2018. After going through this presentation, you are expected to: number 1, illustrate a random variable, discrete random variable, or continuous random variable. Distinguish between a discrete and continuous random variable. Find possible values of a random variable. Illustrate a probability distribution for a discrete random variable and its properties, and compute probabilities corresponding to a given discrete random variable. Okay, let's do this. Letter A, identify the term being described in each of the following. Any activity which can be done repeatedly under similar condition. Example of this is tossing a coin, rolling a die, etc. It is called experiment or trial. The set of all possible outcomes in an experiment. For instance, if you roll a die, the possible outcomes would be 1, 2, 3, 4, 5, 6, because a die has 6 faces. Now we call that sample space. A subset of a sample space is called event. The elements in a sample space is called outcome. The ratio of the number of favorable outcomes to the number of possible outcomes is called probability. Letter B, answer the following questions. Number 1, in how many ways can 2 coins fall? Answer, there are 4 possible ways, and those are head-head, head-tail, tail-head, or tail-tail. If 3 coins are tossed, in how many ways can they fall? So there are 8 possible ways, and these are the possible outcomes. In how many ways can a die fall? So there are 6. In how many ways can 2 dice fall? There are 36. So one die can fall 6, the other one can fall. Number 5, how many ways are there in tossing one coin and rolling a die? The answer is 12 ways. Alright, let's take a look at the random variable. In some experiments, such as tossing a coin 3 times, rolling a die twice, throwing 2 balls from an urn, and the like, we are not oftentimes concerned with every detail of the outcomes. We are usually interested in some numerals associated with the outcomes. For instance, if a coin is tossed twice, the set of all possible outcomes We denote the set of all possible outcomes by capital letter S of the experiment is S, open bracket, tail, 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 head, head, tail, or head, head, then close bracket. If we are interested in the number of tails that came out in the experiment, then we can assign numbers 0, 1, and 2 for each of the four possible outcomes. Now let's take a look at this table. We have the sample space, tail, tail, number of tails 2, tail, head, 1 tail, head, tail, also 1 tail, head, head, 0 tail. From the table above, instead of writing number of tails, we can denote it as set capital letter X, whose elements x sub 1, x sub 2, and x sub 3 are 0, 1, and 2. And in symbol, we write the capital letter X equals open bracket 0, 1, 2, close bracket. We call this capital letter X as the random variable. Definition of random variable. A random variable is a set whose elements are the numbers assigned to the outcomes of an experiment. It is usually denoted by uppercase letters such as X, whose elements are denoted by lowercase letters, the x sub 1, x sub 2, x sub 3, and so on. Example 1. Suppose two coins are tossed and we are interested to determine the number of tails that will come out. Let us use capital letter T to represent the number of tails that will come out. Determine the values of the random variables or variable capital letter T. Okay, let's have a solve the solution. Take note of the steps. There are only 3 steps. Step 1 is list the sample space, capital letter S equals the open bracket. These are the possible outcome: head, 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 tail, tail, head, tail, tail. Count the number of tails in each outcome and assign this number to this outcome. Okay, so these are the outcome. If the outcome is head, head, there is 0 tail. If the outcome is head, tail, so there is 1 tail. The outcome is tail, head, there is also 1 tail. If the outcome is tail, tail, there are 2 tails. So our conclusion, the values of the random variable capital letter T, which represents the number of tails in this experiment, are 0, 1, and 2. Example 2. Two balls are drawn in succession without replacement from an urn containing 5 orange balls and 6 violet balls. Let capital letter V be the random variable representing the number of violet balls. Find the values of the random variable capital letter V. Okay, solution. Let's take a look at the table. List the sample space. So S, these are the possible outcomes. orange, 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 violet, violet, orange, or violet, violet. Count the number of violet balls in each outcome and assign this number to this outcome. Okay, so these are the outcome and these are the assigned number for value V. Now from this, our conclusion would be the values of the random variable capital letter V, which represents the number of violet balls in these experiments, are 0, 1, and 2. Kung mapapansin nyo dito, dalawa yung 1 value V. Pero isa na lang ilalagay natin dyan. 0, 1, and 2. Alright, example number 3. A pair of dice is rolled. Let capital letter X be the random variable representing the sum of the number of dots in the top faces. Find the values of the random variable capital letter X. Okay, solution. So, list the sample space. These are the sample space. So, kung medyo madami-dami, tsatsagayan nyo lang kung ano. Next, count the sum of the number of dots in each outcome and assign this number to this outcome. Because we are interested in the random variable which represents the sum of the number of dots on the top faces. So, okay. Here. Outcome, pag parehong 1 ang lumabas, so sum would be 2. If the outcome are 1, 2 or 2, 1, sum would be 3. If the outcome are 1, 3, 3, 1, or 2, 2, the sum would be 4, and so on and so forth. Okay, so this is our conclusion. The values of the random variable X of the number of dots in the experiment are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now let's have the types of random variables. There are two types, the discrete and the continuous random variable. A random variable may be classified as discrete and continuous. A discrete random variable has countable number of possible values. A continuous random variable can be assumed an infinite or can assume an infinite number of values in one or more intervals. So we have a comparison here of the examples. For discrete random variable, we have number of pens in a box. So number of ants in a colony, number of ripe bananas in a basket, number of COVID-19 positive cases in Sorsogon province, number of defective batteries. While for continuous random variable, examples are amount of antibiotics in the vial, length